This is my solution to Paul McWhorter's picow series, lesson 103, state machine IRQ interrupts. On the right is my solution, on the left is my board that illustrates the solution. Take a look at the code. It's based on my solution to lesson 96, which was the same as the grand challenge, where you had the 2-button up-down counter. And it also uses what Paul did to control one LED. There are two programs shown for the PIO block. The first one is what I call the button manager, and that's this first one. It manages the buttons and notifies the LED state machines about button press release events. The button handling code in here is based on what was done for the 2-button up-down counter. Notice there's one difference in the decorator up here. I've added in shift R is right, and I do that because I like shifting in from the right. When we do an in the program, so we come down to the program, the first thing it does is read the 3 pins that are managing the buttons. And we'll see what those are when we get down to the part where we instantiate. So at this point, because I did the shift right, the ISR bits 31, 30, and 29 contain the value of button 3, 2, and 1 GPIO pins. We shift that value again. This in null 29 shifts those 3 bits to the right 29 places and fills in with zeros on the left. The value is copied to Y, and at this point Y contains zeros up to the low 3 bits, and these are all that are important. And here's what's in those 3 bits. 1 of 8 values, because that's what you can fit in 3 bits. Only 4 of those make any sense for what we're doing. I'm going to ignore the other 4. 0, 0, 0 means all the buttons are up, and we're going to skip that. 0, 0, 1 means the green button is down and the yellow and red are up. 0, 1, 0, which is 2, yellow button down, red, green up. 0, 1, 1, 2 buttons are down, green and yellow, red is up. 1, 0, 0, red is down, other 2 are up. The last 3 are more than 1 button up, and we're going to ignore those. So this first instruction is checking to see what's in Y. If the jump does not occur, in other words, we drop through, that means that Y was 0. All the buttons are up, so we just go back and wait for a button press. So if we take the jump, we come down to not all up, so at least 1 is down. And at this point, we have these values down here now, with Y decremented by 1. And all the other values that aren't shown more than 1 button down, we're going to end up ignoring them. So we know that at least one button is pushed, and we're hoping that we match one of these. We're trying to match one of these. If we do a Y dec now and it fails, that's this first case, which means it's the green button and the green button only that's down, so we drop through. Drop through means wait until that button is up. This is the index of the button. That button is the first of the 3 in the indices. We wait for it to be up, and we take some debouncing. When that's done, we do an IRQ block on IRQ flag 1. What? Not using 0? We're using 1 specifically, and we'll explain why when we get down and look at the other code for the state machines. When that's done, we just jump back for another button press. So we're done. We've waited for a button press. We found what button. We've notified an appropriate LED. We'll scroll down. Same kind of thing happens if it wasn't button 1 down. Now we have these 3 with Y decremented, and we do a similar thing. We do a Y des. If it drops through, that means that it was button 2 and button 2 only that was down. So we're going to do the same thing, wait for it to be up, do an IRQ block. This time we're going to use a 2, and we'll see what this does. I'm saying it does this, but we'll see why. And it jumps back. And then down here, a similar thing. I'm not going to go through the code. If it was neither button 1 or button 2, we take this jump. We're going to do, this time we're down to 2 things, and Y's been decremented, so we either have this case or this case. If you drop through, this is bad this time. If you drop through, that means 2 buttons are down. I'm going to branch down to code that debounces all the buttons. If we drop through here, and we don't drop through. If we take the branch, we come down to check button 3. So at check button 3, we're down to this 1 case, and it should look like this. So we do the decrement. If it doesn't drop through, we go to the debounce all. And do the same kind of thing. We wait for that button whose index is 2, which is going to be the 3rd button, to be up. And now we do IRQ block with an index of 3. We'll see why. And jump. The debounce all just waits on all 3 of them to be up and throws in some debouncing. The other PIO. We'll do those comments. Well, I can put it all up here, I think. Let's see. This is code for the 3 state machines. Each one handles 1 LED. So all 3 state machines are going to use this. It's just like what Paul had with 2 exceptions. Here's the first exception. He just had a 0 here. I have rel 0. And the comments below explain that, but just bear with me for a minute. And the other thing is I did not do an IRQ clear. How many instructions? Total now, this is all. The first one has 27. This one has 4. Total of 31. So I used 31 of the 32 instructions. So let's take a quick look at these comments. First one, a wait with 1 IRQ and then anything for the 3rd parameter behaves slightly differently. The selected IRQ flag is cleared by the state machine upon the wait condition being met. So it's actually part of that wait being satisfied. So you don't have to explicitly clear this flag. If you watched my video on how I solved the 2-button up-down counter, I used 2 state machines, and I had to synchronize between them using one of these, and took advantage of that. Very important. The second thing explains what this is why you don't need the IRQ clear. Second thing is, what is this rel 0 thing? The rel 0 value is computed as follows. The state machine ID, in our case it's going to be 1 through 3, state machine 0 is the one that manages the buttons, is added to the IRQ index by way of a modulo 4 addition to the 2 least significant bits of the index. Well, the two least significant bits of 0 are 0, 0. If we add 1, 2, or 3 to that, we get 1, 2, or 3. So the state machine 1 will have rel 0 of 1. The state machine 2 will have a rel 0 of 2, and a state machine 3 will have a rel 0 of 3. So that's why in the first program we had the IRQ block 1, 2, and 3. All right, that's it for that. Let's go down and look at the final part. Here's the final part. We define the buttons. The button pins are 11, 12, and 13. Green, yellow, red. The LEDs, 20, 19, and 18. Green is 20, yellow, 19, red, 18. Instantiate the state machine, and the end base pin is button 1, and that's why that index 0, 1, 2 was done in the wait for button up. We instantiate the 3 state machines that manage the LEDs, and you'll notice that they use the same program. We activate the button one, wait just a bit, make sure it's initialized, and then activate the other 3. And that's it. The rest of this is just doing a sleep, and so the program will end. So now I'm going to run the program. I've got a minute, so I'm going to push the green button, green on, yellow on, red off, green off, yellow off, red on, red off, green on, green off. Now I'm going to hit a couple of the buttons simultaneously. That was green and yellow, yellow and red, so I must not have done a very good job. Let me do it again. That was yellow and red, and here's green and red, and here's all 3. Let's make sure the buttons still work. There's green, yellow, red, red off, yellow off, green off, and I think that'll do it. I don't know how we're doing here, but that's the end. Thank you for watching.